Right, so I've asked us to find our x and y value for our stationary point and determine whether it's the maximum or the minimum value for that function, correct? What type of function have we got? Quadratic. So we know that's going to be a smiley face or a sad face, correct? So our stationary point is going to represent either a maximum or a minimum. If we're really aware, we'll see what type of quadratic function we'll know, and we'll already know from the start whether it's going to be a max or a min. So, Kansas, what's my first step here? Yeah, so what do we call that? You're right. Yeah, is my first line of work incorrect so far? Yeah, and that dash is called deriving. Okay, so we need to use calculus, that new skill set that we have. So when we derive, what's the rule?
4x+8.
Thank you, Kansas. It is 4x plus 8. Very observant. Then what do we do? Thanks, Harriet. I'm looking for a stationary point, so I need to. Yep. Let x equal 0. I let f dash x equal 0, correct? Next step. Remember when I told you in year 8 that rearranging is kind of important because you'll do it all the time? And you're probably sick of me saying that because you've heard it a number of times. Reverse BOMDAS, opposite operation. X equals? -2. You got that? Good. That's only a third of the problem, but correct? What would you like me to do first? Determine the y value or determine whether it's a max or a min? Y value? How do I find the y value? Substitute x equals -2 into my function, my original function, not my derivative function. So I've got 2 times -2 squared plus 8 times -2 minus 6. What's -2 squared? Times 2. 8 minus 16 minus 6, which equals -8 minus 6, which equals -14. So I know that my turning point or my stationary point occurs at SP occurs at -2, -14. Are we happy with that? So what's the only part of the problem that I haven't solved yet? Do we know how we do that? We did something pretty similar yesterday. What did I do yesterday when I wanted to determine what my turning point looked like?
Just surrounding points?
Yep, surrounding points. So I put -2 and 0 here, correct? So what other points do I need to look at?
1 and -1?
I could use -1 and I could use 1. I could use another one that's even easier. 0? Doesn't matter what point I pick as long as it's to the left or right. So I could have used 1. Nothing wrong with using 1. The reason I use 0 because I can just get rid of anything with x, correct? So I shove that into my original. I'll just remind us what our function is. F dash x equals 4x plus 8. -1's not going to work. Why is not going to work?
Large, -3.
Very good. It needs to be less than -2, so it needs to be -3. So now, if I shove x equals 0 into my function, what do I get?
-6.
This function. 0 times 4 plus 8. Do I care that it's 8? What do I care about? It's positive, correct? -3 times 4
-12.
plus 8.
Negative.
Do I care? Negative what? -4. I don't care that it's -4 though, do I? I just care that it's negative. So what I want you to do, just to identify where we're going here, that's going to be a straight line, correct? I want you to draw a negative tangent and a positive tangent above each of those corresponding tables. So what will a negative tangent look like? I don't care about the steepness as long as it's negative. Who got something like that? So what does that tell you this point is? Minimum. That's a minimum value, correct? Because that's the lowest point it's ever going to hit. Cool? So if we go -0 positive, we're dealing with a minimum. What if my function went like this? +0, negative. Dealing with a maximum, correct? Now, because I picked a gentle function where we knew, how did we know initially it was going to be a minimum? Some of you would have known, I'm hoping, that this was going to be a minimum the moment you saw that equation. How do you know?
From the gradient.
Yeah, from the gradient, but how else? What? And Haley, you got an idea? No. Is that a smiley face or a sad face?
Smiley face.
Smiley face. So the turning point in a smiley face is at the bottom, correct? So that's going to be a minimum. So we knew it was going to be this one from the start, which told us we were going to be dealing with a minimum. This is just a proof of that. And obviously when we go down the track, we're not going to be dealing with just simple quadratic formulas. It's going to get a bit more tricky. We're going to be dealing with all sorts of different types. Happy with that? So what's the process for identifying a max and a min? What do we need to do? First step was? Derived it. Second step? Let it equal 0. Find your x values where that occurs. In this case there was 1, but could there be more in other examples? There could be a number of x values. Once we've got our max and min point, if we are required to find the y value, we find the y value. If not, we put it into a table and we pick a point where? How do we pick our points? One higher and one lower, and then we identify whether the gradient is positive or negative. And then if you're struggling, don't be afraid to actually physically draw it in. I still do that, because I can visualise what's going on. Cool? I'll give you another one to practice on that.